Hi guys, for today's lesson we're going to be dealing with quadrilaterals and other polygons. So first up, what do I mean by a polygon? A polygon is a 2D shape with straight edges. So things like squares and rectangles, they're 2D shapes and they've all got straight edges. Things like circles and semicircles, they're not polygons because they have curved edges. Quadrilateral, it's a type of polygon with 4 sides, so e.g. like squares and kites. So things like pentagons or hexagons, they're not quadrilaterals. Interior angle, it's the inside angles of a polygon. So these are the interior angles. Interior means inside. Exterior angles, the angles made on the outside of a polygon when a side is extended. So the idea is that exterior angles are kind of like the angles on the outside of a shape, but you need to have extended a side further than just the shape. So there's my triangle, and I've made that side longer to make an exterior angle on the outside. Exterior angles are always less than 180, so it's definitely not this one on the other side. That's a 180 degree angle. It's definitely the one that is less than 180. So some rules to remember: the sum of interior angles for a polygon differs depending on the number of sides. So e.g., this angle sum of a triangle is 180 degrees, but for things like quadrilaterals or pentagons or hexagons, the angle sum is going to be different. And this formula allows you to figure out the angle sum. So you change this n to the number of sides on your shape, and this will give you the angle sum. So e.g., consider a regular pentagon. A regular shape is where all angles and sides are equal. So using the formula, our n is going to change to 5 for a pentagon, and that's going to make 540. So that means the angle sum of this pentagon here is 540. So A plus B plus C plus D plus E, all these angles here, they're going to add up to 540. Because all the angles are equal, we can take that 540 and divide by 5, and we can figure out that each of these angles is equal to 108. Okay, moving on. So the sum of exterior angles for a polygon is always 360, no matter how many sides the polygon has. So for example, we figured out that each of these angles here was 108, as you can see here. That means that the exterior angle is going to be equal to 72. They're going to add up to 180. And that means that all of them are going to be 72 as well. And you can see that 5 lots of that 72 gives you that sum of 360, which it should be. Here, this triangle, you can see the interior angles. That means we can find the exterior ones as well. And according to this rule, these exterior angles should always add up to 360, and that is exactly what they do. Okay, so here are some specific quadrilaterals, and specific quadrilaterals are defined by their properties. So pretty much, if we have a look at this diagram, you can see here that we're talking about quadrilaterals here, all 4-sided shapes, and here's a pretty wonky looking quadrilateral. But if I decide to make a quadrilateral that has 2 pairs of adjacent equal sides, so these 2 sides up here are adjacent, they're next to each other, and they are equal, and I do that for another pair down here, that means I've got a kite. So a kite is a type of quadrilateral which has this sort of property. So literally any sort of shape with that property is going to be a kite. Over here, any sort of quadrilateral with 1 pair of parallel sides, as you can see here, that is going to be a type of trapezium. So I can make a really wonky shape, but all I need is a pair of parallel sides, and that's going to be a trapezium. If my trapezium has 2 pairs of parallel sides, so say if that side was parallel to that one, it would become a parallelogram. So a parallelogram is technically a type of trapezium where it has 2 pairs of parallel sides. And if that's the case, you'll notice that some of these diagonals, these dotted lines, they're going to sort of bisect each other. They're going to be halved because those 2 lengths there are the same length. If I've got a parallelogram and one of the angles is a right angle, so one of these angles here becomes a right angle, suddenly I get a rectangle. So a rectangle is a type of parallelogram, which is a type of trapezium, where you've got these right angles in the corner. And you'll notice that with rectangles and parallelograms, the opposite sides are also equal. Like that's what happens when we get this sort of when these sorts of properties are happening. Okay, say if you've got a kite and then suddenly all the sides are equal instead of just having these two pairs, then you get a rhombus. And that's the same with if you have a parallelogram and suddenly you get all sides being equal as well. So a rhombus is a type of parallelogram, but also a type of kite. It satisfies, a rhombus satisfies the properties of a kite, and it also satisfies the properties of a parallelogram. So like these sorts of shapes are just getting more and more detailed. Say if you've got a rectangle which has all sides being equal, then suddenly you get a square. And say if you have a rhombus that has one of its angles being a right angle, then suddenly you get a square as well. So a square is technically a type of rhombus, rectangle, parallelogram, trapezium, kite, and quadrilateral all at the same time, which is very strange, but it's the case. Okay, let's do some example questions. So find the value of x. So if I give you this polygon, it's irregular because not all the angles are the same and the sides aren't the same. We need to figure out what all these angles add up to figure out what our value of x is. So we use the formula for the interior angle sum. So it's S equals 180 n minus 2. S stands for sum. Our n is going to change to a 5 because we've got 1, 2, 3, 4, 5. It's an irregular pentagon. So that's going to come out with an angle sum of 540. We add up all these angles and let them add up to 540, and then we can solve for x. So 2x plus 55 plus 95 plus 110 plus x plus 100 equals 540. That simplifies 3x plus 360 equals 540, and we end up with x being equal to 60. Question 2, find the number of sides of a regular polygon. So that means all the sides and angles are the same, with each exterior angle being equal to 40 degrees. So the idea is we know that all these exterior angles have to sum to 360. So we can figure out the number of sides by thinking, well, every single side you can make an exterior angle with these sides. So pretty much we can figure out the number of 40 degree angles within that side. Within that shape, and so we can do 360 divided by that 40 degree angle, and that means that there's going to be 9 sides when we do that division. So I hope this helps. Good luck with the questions.